Hey everybody, what's up? Ooh, how you doing? So, do you like my little twins guy over there? So today we are going to talk, there you are. We are going to talk about the quadratic function, and specifically the vertex and the different forms and how we can go from the form to the graph. Again, I'm not getting paid a dime for this, but Desmos.com is an incredible place to understand literally just like the mechanisms. It's like a machine. Equations are a machine, okay? It's like when I go into my bathroom and I turn on the faucet for the cold, I know a result I'm gonna get. If I turn on the faucet for the hot, I know a result I'm gonna get. If I mix them in between, right, now I'm trying to figure out the levers for a different temperature because I'm mixing them. Well, in a lot of ways, in practically every way, math equations are like that. What we call formulas are really just the narrow bits of zeros and ones that iterate from this form and this idea that we've established about knowns and unknowns inside of the coordinate plane and the graph that ensues. Okay, so I know I get philosophical every time. It's gonna happen. Let's just accept it together. All right, let's roll the videotape. We've got, I forget which guy that is over there. All right, here we go. On to mathematics. Okay, so let's consider what is the quadratic, hello, I don't want purple. What is the quadratic function, right? What is that? This is basically, this is the equation, and this is the shape. They are intimately linked, okay? It's like if I say, what is your name? This is your name, okay? And then I go and I meet you face to face, and that's what I get, right? I go, oh, now I can put a face with the name, right? Hi, my name is Becca, and this is what I look like, okay? That's what's happening. So if you hear this and you get confused in math class, this is just a parabola is the graphic representation of a quadratic function, okay? So we've always got our graph here. Let's label some things of a quadratic, okay? We've got our coordinate plane, x, y, right? This is always going to be a right angle. We have to do a lot more geometry. There's so much wonderful math to cover all the time. Okay, so let's do a straight up, just a typical parabola. I'm actually going to try to graph this true to form. So this is the equation of just simply y equals x squared. So when you have a power squared, it's this every time, okay? Well, it's this if it's just that. So this is called the vertex, right? This is called the vertex. And the vertex is this where it slopes. Now the vertex, this word, every parabolic function, every conic section, okay? And we know conic sections come out of the vortex of the cone, okay? Every conic section has a vertex, and the one that is straight across is, so here are the conic sections. There's a circle, and it doesn't have a vertex, it has a center. For every other one, there's a vertex, okay? So that's a circle. If it's at an angle, you're gonna get a shape called an ellipse, okay? And you might recognize, if you get both, if you go straight up and down, okay, you get an hyperbola, and 1/2 of a hyperbola is a parabola, okay? It's just half. It's half of the hyperbola. And in fact, I'm realizing as I'm talking to you guys that I don't actually know where these words come, and it's gonna bother me. So I'm gonna figure that out for you tomorrow. Okay, so those are conic sections. Conic sections, of which actually a line is a conic section too, but it's got to go straight down. So a parabola has this form. All the conic sections are related, okay? All of them. And it has this shape. So this is the quadratic function, and that's the parabola. And these two, in this moment, this exact equation is that exact graph. The exact, okay? Now, you can come up, let's go back to XY, okay? You're probably like, Ms. Thompson, how did you graph that quickly? Okay, X, because I'm going to show you how they shift now. So Y equals X squared. That's what we had, right? So you could say a table of values, right? X and Y. Do you remember doing this in Algebra 1? And you pick some typical values, which is exactly what I did. You get to pick X. Why do we get to pick X? Because X is the independent variable, okay? Both of these are variable. They're not fixed. They relate with each other. They're like a married couple. X and Y have like the greatest marriage of all time because they've been together for hundreds of years and they've never died. And in fact, they were together even before they were discovered because they're, so see, I graphed a line and a line, so I guess I better get rid of that. I don't want to cause confusion. Okay, so that's the independent variable. It can be whatever we want it to be. This is, the Y is, what's the inverse of independent? It's dependent, okay? Y depends on X, okay? I'm really hoping you're with me right now. If you're not, go ahead and pause the video. Go back in time. Okay, if you're feeling it, let's keep going. So what do we do with these? Hopefully you remember, right? You plug this value into here to get that value so that you can graph it. Well, 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1. That's what makes the parabola bounce back, right? And that's 4, okay? So then we graph it, 1, 1, 2, 4. You see these things? Negative 1, 1, negative 2, 4. You could do this, negative 3, 9, right? Okay. This is a little scritchy scratch, but you see it again, right? And there we've got our vertex. Well, what's nice about something, so this is how I had to grow up doing it, and all your parents had to grow up doing it, is by hand on a piece of paper, okay? We didn't even have iPads. You really should feel like a little twinge of like for your parents and how hard we worked to get where we are. Like, let's be plain. Okay. And if you are your parents' age, hey, how you doing, pal? That means we're probably contemporaries. Okay. Now, again, I'm not getting paid by Desmos, but Desmos.com is a great way to see what happens, okay? So when we have y equals negative x squared, okay? That's all we've done so far is negative x. Can we predict what happens quickly? I almost missed my snap. Quickly. I'm better with the right hand. Can we predict what happens quickly? Well, this is like riding a bicycle, okay? When you start really little, it's going to be challenging. Same values, but in here now. Well, 2 squared, this is where order of operations comes in, okay? Where does the negative go? It's last, because this squared is more powerful than the negative, okay? So you get 2 squared, just like here, is 4, but then at the last second, it swaps to be negative 4. Okay? So every single one of these values is the inverse. And what happens? Here are our points, and our parabola goes down. Okay? But we still have, but you notice the vertex didn't change. It's still 0, 0. There is a reason for that. Okay, so we've got this function. And we're going to show it to you this week. So I got to fix, my B's are a little, they struggle to look like a B. AX squared plus BX plus C. Which when the top level, I'll call it, it's the dimension is 2, it's always going to be a parabola. Unless you're dividing, but don't worry about that yet, okay? Everything has a form. So this is, I should give you the right word there. It is a quadratic. And you know that because of this 2. And you write in descending order. Okay? So, y and x are y and x always, right? Y and x. There are directions. They're these. They're the variables. A, B, and C are constants. Okay? So, I like to say it this way. If you start, I know Facebook is for your parents. I get that. I know it all the time. If you start a new Facebook page or a YouTube channel or an Instagram handle, right? When you go into one of these things, right? They have a template. You're allowed your name, right? You're allowed your profile picture. You're allowed your banner headline, right? X, Twitter, X, right? They're the same. You get your name, you get your profile picture, and you get your banner headline, right? But yours are going to be different than mine. That's how we differentiate our different handles, right? So that your TikTok doesn't get confused with my TikTok, right? But the form that TikTok and Meta and Google and X use is this. They're using a form, you're drawing it out, okay? So let's see what this form does. Let's see what we can iterate this into not only the quadratic formula, but also into a different form, and I will iterate these things for you into this. Okay, this is the same, now see, squared, okay? These can iterate between each other, and by iterate, I mean they can change, these two things are the same equation. Okay, let's be clear. Same equation, just different forms. This is the form of, this is the form of name, profile picture, banner headline, right? This is the form of vertex, slope. Now, so this is vertex, these 2 points, vertex, right? So that helps us know where this point is. Right? Now, I want to show you what is the equation of a line that we all know? Y equals, ready for it? You remember, right? But this is a linear function. It's one dimension. It's in the first dimension. So if we had this and we got rid of that part, look at that. Y equals, right? Let's just say we got rid of this part. I'll put my thumb over it, literally. Bx plus c. Well, doesn't that look like the same form? Because B and C are just constants. M and B are just constants. Now, why do we use different letters? I don't know for why, but the key are these two stay the same. So this is a linear form, and there's the linear form. And when you add a new dimension, we're going to use the proper math terms. I'm not going to give you all this nonsensical stuff that only lasts for a single unit, and then you go on to the next year of math, and it's all changed. I'm using the actual terms that you actually need for actual mathematics and physics, okay? And chemistry and everything. This is the new dimension, okay? But you're just piggybacking on this idea, right? So the same way, this is not a slope. It's not. But the same way that the slope moves, the A moves. So A changes. It can, if it's negative, it can flip the whole parabola. Okay, it can make it narrower, or it can make it wider. Oops. And that's the equivalent to the slope being below zero, below perfect 1 degree. That would be, so if A is greater than 1, your parabola is gonna tip up like a high slope. If A is less than 1, it's gonna go wider, flatter. Do you remember the video? I'll link it on here. The video of running with the slope, okay? Because this is like the slope. It's not the slope, they're different, but it acts like the slope, okay? Meanwhile, the vertex is flat out HK. So what does that do for us? Well, let's give an example now, right? Example, y equals x minus 2 squared plus 4. Okay, what this means, there's nothing written here. So what does nothing written there means? It's the identity, which is 1, which means it's the same, which makes it the exact same as this. Well, this one, right? With the 1-to-1 relationship, 1, 1, 2, 4. It's going to be the exact same because the A is 1. That means the form is the exact same. And the vertex is where? The vertex is, I know a lot of you are going to want to say, well, is this correct? Is that correct? No. Which part is incorrect with the form? Vertex. The form is negative. That means the part is actually positive. So that makes it that I can very quickly, I'm at the page break, graph this. I go, okay, I'm going to go to 1, 2, 1, 2, 3, 4. Oops, I'm going to redo that graph. Give me a hot second, because I want to make it where I can get it all in. I get to declare where my stuff is, right? X, Y. So the vertex is at, here's center, origin, right? 0, 0. 1, 2. 1, 2, 3, 4. There's my new vertex. And now without plotting a point, I know where they are, right? Because I said it takes this same form. Why does it take that same form? Because our A is 1. Okay, I didn't monkey with that this time. We'll talk about that a different time. We'll do another example. So I can go from the vertex, 1, 1, negative 1, 1, 2, 4, negative 2, 4. And just for super happy fun time, to prove that I'm correct, that this is our parabola, let's check this point. When y is 0, okay? Oof, we're going to have to actually do some math on that, like some real arithmetic. When x is 0, see, I knew it was easy. Y equals 0 minus 2 squared plus 4. First of all, before we do our big reveal, let's count where that point is. 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 0, 8. So our answer should be 8. Well, lo and behold, negative 2 squared is 4. If you tried to solve this where y is 0 and see if there's x-intercepts, you're not going to get an answer because it doesn't cross the x, which we'll talk about that another time. No, let's talk about it right now. Let's see if there are y-intercepts, okay? We can see that there are not, right? Are you with me? There are no y-intercepts. So let's prove it to ourselves. So we'll put 0 in for here because 0, that's how we do it. So when y is 0, so here's y, there's 0. There's the 0 of y. So when y is 0, we have this equation, right? Now what happens if we try to solve it? Negative 4 minus, subtract 4 from both sides. Negative 4 equals x minus 2 squared. Take the square root of both sides, and we get x minus 2 over here. And am I allowed to take the square root of a negative number? Doesn't matter what it is. Am I allowed to do that? Oh, Now, some of you are reading this, and you're seeing it, and you're like, oh my gosh, she's probably wrong, because you see this, and you go, that's plus or minus 2i. And you're correct on the complex plane, but we're not on the complex plane, right? That's like saying if I go north and a little bit east, X amount of miles, I'll end up at the Atlantic Ocean. If I go 10 miles east, I'm at the Atlantic Ocean, okay? I would have to be starting somewhere on the East Coast, and I'm not. It's not possible from where we are, okay? We are not in the complex plane. So, I like to keep these to 20 minutes. We did an example and showed you a lot of things. I am going to iterate this along with this bad boy. So we'll end on this. What is this thing? Do you remember this? Shoot. Nope, it's not that. Come on now, Thompson. You don't start with that. That ring a bell? Those A, B, and C's are these, right? So this is standard form. This is vertex form. And then this is the quadratic formula that solves it. We'll do that next time. I turn off my pen. The pen is as mighty as the sword. Or mightier, depending on what you're doing. So we're spending a lot of time on the quadratic formula. We've spent a lot of time in quadratics. I was thumbing through ideas, and I just figured it was another good one. Thanks for coming along. Bye.